All right, and another thing that we can do with the combined gas laws, we can derive gas laws from the combined gas law. So we can derive each of the gas laws from the combined gas law. Let me show you what I mean by this, and then we're going to do some example problems. Your practice for today is going to be these example problems that are listed below. So now that we've done some problems, and we're going to go through this, maybe after you've seen one or two problems, you can figure out how to do the rest on your own, and the videos after this one will just be optional, or you can check your answer and see how you did. So according to Boyle's law, the things that are held constant are the number of moles and the temperature. So that means pressure and volume are the only things that are changing. So if the moles and the temperature are held constant, all that's left is P1 times V1 equals P2 times V2. So I'm just crossing out whatever doesn't change. The only thing that I'll include in my law is what's changing. What's changing is P1 and V1 change to P2 and V2. So if the only things that are changing are pressure and volume, it's P1 V1 equals P2 V2. Now according to Charles's law, the number of moles and the pressure are held constant. Charles's law is volume and temperature. Those are the only two things that are changing. So you can see that it's V1 divided by T1 equals V2 over T2. And then according to Gay-Lussac's law, the number of moles and the volume are held constant. So this is just a relationship between temperature and pressure. So we're going to get rid of the volume aspect of this, and we have P1 over T1 equals P2 over T2. Now, this next example maybe illustrates a little better what I want to get at. So let's look at this example number 1. I'm going to use my formula. The combined gas law formula is P1 V1 over T1 equals P2 V2 over T2. All right, so that's my formula. I want to read this question and decide what's changing. It says 2.00 liters of a gas is at 740.0 millimeters of mercury pressure. What is the volume if the pressure is changed to standard pressure? Now the standard pressure, remember, that is 1 atmosphere, which is also equal to 760 millimeters of mercury. So you need to know what these units mean. So we have two pressures. We have an original pressure and we have a final pressure. So I have P1 and P2. I have a starting volume and I'm looking for my final volume. So the two things that are changing are pressure and volume. So that means I'm going to get rid of the things that are not changing, the things that are constant, which in this case is temperature. I don't need the temperature factor. It's just P1 V1 equals P2 V2. So I'll solve that. P1 V1 P2 V2. P1 is 740 millimeters of mercury. And V1 is 2.00 liters. P2 is going to be standard, which is 760 millimeters of mercury. And V2 is unknown. It's an unknown number of liters. Now I'm going to solve it right here. P1 V1 equals P2 V2. So I have 740.0, that's P1, times V1, 2.00, equals 760.0 times V2. If I wanted to solve for it, I could divide both sides by 760.0. Cancel that out. I'm going to end up with V2 equals 1.95 liters. All right, after that, you probably could do the next question. So maybe you could do this one on your own. Why don't you pause the video, try it yourself, and then come check your answer afterward. Again, we're going to be using that same formula. P1 V1 over T1 equals P2 V2 over T2. All right, we've got that. Let's read the question. I have a 30.0 liter sample that looks like volume inside a rigid metal container. Now wait a second. Rigid metal container. We want to know what that means. Rigid means volume does not change easily. It's got 20.0 degrees Celsius. It's placed inside an oven whose temperature is 50.0 degrees Celsius. The pressure inside the container at 20 is 3.00 atmospheres. So at our original temperature at T1, it's 3.00 atmospheres. That's P1. It says, what is the pressure after its temperature is increased to this temperature? The T2 would be 50.0 degrees Celsius. So you see, pressure and temperature is the relationship we're looking at. Now it says it's a 30-liter rigid metal container. Does the volume really matter? Actually does not matter. It does not change. It's going to stay constant. So I will eliminate volume from this in order to solve it. So my equation in this case is going to be P1 over T1 equals P2 over T2. It's a little more tricky question than some of the others. So P1, T1, P2, T2. Where P1 is 3.00 atmospheres because it's the one that goes along with our initial temperature. So we have a T1 of 20.0 degrees Celsius, a P1 of 3.00 atmospheres. Don't forget to add 273 every time that we have Celsius. So that's going to be 293 Kelvin. P2 is what we're looking for. And T2 is this. It's 50.0 degrees Celsius. So we need to add 273. That's 323. Sorry, that's 323.0 Kelvin. Then we'll solve for it. So I have P1 over T1 equals P2 over T2, 3.00 over 293.0 equals P2 over, and T2 is 323.0. To get P2 by itself, I could cross multiply and do 3.00 times 323.0 divided by 293.0. That's going to give me my number of atmospheres, 3.31 atmospheres. All right, try your hand at the remaining questions. We'll post an answer key, but also some videos to walk you through them.